motion and time. It is a common observation that all living objects, whether plants or animals, can move in some way or the other. The motion in animals is more apparent than the motion in plants. A dog running to catch a ball thrown in the air, a horse pulling a cart on the road, a pair of oxen pulling the plow in the fields are all examples of motion in animals. Just like humans can move, run, and jump, animals also have the ability to move a part or whole of their bodies. All the objects travel with a different speed. Speed. Speed is defined as the ratio of the total distance traveled by a body to the total time taken to do so. It is also defined as the distance traveled in a unit time. Mathematically, it is given by the expression speed is equal to total distance covered upon total time taken, or S is equal to d upon t. Speed is measured in meter per second and is also measured in kilometer per hour. In our daily life, we find objects moving with a constant speed over long distances or for long durations of time. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. Whereas an object moving along a straight line with a constant speed is said to be in uniform motion. Uniform speed. If a body covers equal distances in equal intervals of time, then its speed is said to be uniform. Example, suppose a scooter travels 10 meters every 5 seconds, then the speed of the scooter is said to be uniform and is given by speed is equal to 10 upon 5 is equal to 2 meter per second. Variable or non-uniform speed. If a body covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, then its speed is said to be non-uniform. For measuring speed, we need to have two things: distance moved by the object, time taken to move this distance. Measurement of time. Our ancestors measured time by noting the motion of the stars and the earth. They found that some events in nature repeat themselves after regular intervals of time. For example, they found that the sun rises every day in the morning and sets in the evening. Clocks and watches are the most common time measuring devices. In the laboratory, we measure time with the help of a stop clock. Nowadays, most clocks or watches have an electric circuit with one or more cells. These clocks are called quartz clocks. The time measured by quartz clocks is much more accurate than that with the clocks available earlier, that is, a digital clock. All clocks make use of the periodic motion, a motion which repeats itself after regular intervals of time. The most common periodic motion is that of a simple pendulum. Simple pendulum. A practical pendulum consists of a small, heavy brass sphere called bob, suspended by a long, fine thread from a rigid support. When the bob is displaced from its mean position, then it begins to oscillate in a vertical plane under gravity to and fro about the mean position. This to and fro motion of a simple pendulum is an example of a periodic or an oscillatory motion. Mean position of the pendulum. It is the position of the pendulum when it is at rest. In this position, the thread of the pendulum is vertical. Extreme position. It is the maximum distance on both sides of the mean position up to which the pendulum can oscillate. there are two extreme positions of the pendulum. These are represented as A and B. One oscillation is completed when the pendulum moves from the mean position to one extreme position, from this extreme position back to the mean position, from the mean position to the other extreme position, and then back to the mean position. One oscillation is said to be undergone by the pendulum when it moves from A to B and back. The motion between extreme position and the other is half an oscillation, while from the mean position to the extreme position is 1/4 of an oscillation. The time taken by a simple pendulum to complete one oscillation is called its time period. Units of time and speed. Time is measured in second, its symbol is S. Time is also measured in minutes, hours, days, years, etc. Different units of time are used to measure different intervals of time. Example, your age is measured in years and time taken to complete a 100-meter race in seconds. Speed, as we defined earlier, is the ratio of total distance traveled to the total time taken. Therefore, speed is measured in meter per second, which is written as ms-1. Some other units of speed are kilometer per hour, km/h-1, kilometer per second, kms-1. Measuring speed. Speed can be measured in many ways. Using the measurements of a speed trap, the speed of the car can be calculated. Suppose the car takes 3.9 seconds to cross 50 meters. Use the equation speed is equal to distance traveled divided by time taken is equal to 50 upon 3.9 is equal to 12.8 meter per second. Different objects have different speeds. Rockets, which launch satellites into Earth's orbit, often attain speeds up to 8 kilometers per second, whereas animals like tortoise or sloth can barely move at the speed of 8 centimeters per second. One such instrument is called a speedometer. A speedometer notes the speed directly in kilometers per hour. There is another meter known as an odometer which measures the distance moved by the vehicle. Distance time graph. A graph is a line, straight or curved, showing the relation between two variable quantities of which one varies as a result of the change in the other. The quantity which is made to vary at will is called the independent variable, and the other, which varies as a result of this change, is called the dependent variable. Thus, the distance traveled by an object and the time taken to do so can be shown through a graph. In other words, a graph is a pictorial representation of variation of one quantity with respect to the other. Graphs are of different types, like a bar graph, a pie chart, or a straight line. Plotting a graph. Graphs are usually plotted on paper, ruled in millimeter or in squares. On a suitable graph paper, two thick lines at right angles to each other are drawn at the bottom of the left-hand side of the paper to indicate the two axes, x and y axis. The independent quantity is then represented along the x-axis and the dependent quantity is represented along the y-axis. A convenient scale is shown to accommodate the smallest as well as the largest observation. Various points are then plotted for various pairs of observation by drawing a small circle around each of the points plotted. If the graph seems to be a straight line, draw a straight line passing through maximum of these plotted points. Give a suitable name to the graph plotted. If the distance-time graph is a straight line, it indicates that the object is moving with a constant speed.